Because they are so common, taking calculators for granted is easy. But today's electronic calculators are astonishing devices. Welcome back to Explaining Difficult Stuff. In this brief video, we'll look at how today's calculators work. We promise that you do not have to be a computer scientist to follow. This video explains binary numbers in simple terms. It is the language calculators and computers use. We will also get into microchips called logic gates. They give calculators the ability to figure things out. We will not go deeply into these concepts. Each would require a book. But you will get a very good understanding of today's electronic calculators. Like words, numbers can be expressed in different languages. We communicate using familiar decimal numbers. However, electronic devices communicate in binary. So, let's take a look at the basics of binary numbers. To gain a basic understanding of the binary number system, let's compare it to the decimal system, which we are more familiar with. Humans use the decimal system. Calculators use binary. The decimal system is a base 10 system. Deci in Latin is 10. The binary system is a base 2 system. Bi as Latin is 2. The decimal digits are 0 to 9. Digits in the binary are called bits. There are only 2, 1 and 0. Numbers in both systems are developed column by column. First, let's develop a number in the decimal system. An endless number of columns could be used, but for this example we will use 5. Each column is a greater power of 10. 10 to the 4th power is 10 times 10, times 10, times 10, or 10,000. 10 to the 3rd power is 10 times 10, times 10, which equals 1,000. Likewise, 10 to the 2nd power is 10 times 10, or 100. And 10 to the 1st power is 10. Let's assume we're trying to develop the number 73,095. To get there, we will multiply each of the columns by one of the 10 decimal digits. The first thing would be to multiply the 10,000s column by 7, which would give us 70,000. Next, multiply the thousands column by 3, bringing the combined total of the first two columns to 73,000. Not to go over our target, since only 95 more is needed, the 100s column would be multiplied by 0. Next, the tens column would be multiplied by 9, bringing the total to 73,090. With only 5 to go, the ones column would be multiplied by 5. The total of all 5 columns therefore would equal 73,095. Although we don't realize it, every time we create decimal numbers, we do it column by column. Binary numbers follow the same procedure, with two notable exceptions. First, each column in the binary number system represents a power of 2, not 10 as in the decimal system. The other exception is that each column can only be multiplied by either 1 or 0. Like we did developing a decimal number, we will develop a binary number the same way. Let's use the number 27 as our target. First, the 16ths column would be multiplied by 1. The 8ths column would be multiplied by 1 as well, bringing the combined total of the first two columns to 24. Since we are only 3 away, the 4s column would be multiplied by 0. After the 2s and the 1s columns are each multiplied by 1, we would reach our target of 27. The binary code number for 27 is 11011. When you push the decimal numbers 2 and 7 on a calculator keypad, those numbers must be converted to binary for the calculator to perform calculations. When keys are pressed, an electrical connection is made, and current flows to microchips called logic gates. Each of those silver tabs is a gate that swings open for a 1, and remains closed for a 0. In the case of the number 27, the pattern of the 5 gates would be open, open, closed, open, and open. Or in binary code 11011, which equals 27 in decimal numbers. Let's tie it all together by looking at it from the calculator's point of view. First, someone picks you up and enters the number 27, which you post on your display. Then they press your plus key, which alerts you that another number is about to be entered, in this case, 15. Because you don't understand decimals, you use a tiny unit called a translator, to convert the decimal input to binary. Once translated, you send the binary code for number 27 to one memory unit, and the code for 15 to another. There, they await your instructions. Then when someone presses your equal key, you release both numbers to a logic gate to perform the calculation. In this case, the binary code for 42 is generated based on which of those little silver tabs are opening for 1s and closing for 0s. You have worked out the answer, but you're not done yet. Because humans don't understand binary, you use another translator to post the answer in decimal form on your display. At that point, your job is done, and it only took you a microsecond. Other logic gates subtract, multiply, and divide. For the sake of simplicity we will not go through them, but you get the idea. Congratulations! You made it to the end. You know more about calculators now than you did a few minutes ago. As mentioned earlier, the topics we explain are often more complicated and technical than the basics we cover. If you want to dig deeper into today's electronic calculators, see the link below. If you enjoyed this video, please hit the like button and subscribe to Explaining Difficult Stuff. Every time someone subscribes, it makes our day. We appreciate your giving us the incentive to keep explaining difficult stuff to as many people as possible. Help us get the word out by sharing this video. Thanks for watching Explaining Difficult Stuff. By the way, there is no cure for curiosity.